Okay, Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome you to this class, EET522, the distributed generation. This is I believe, the fourth chapter of this course. The first part of this lecture already been covered by Dr. Samila, and then this will be the second part of the lecture. But for my part, I will only cover the distributed generation technologies. Okay, and for this part, the part one that we have for the distributed generation, I will cover the solar thermal energy. Okay, this is the worldwide renewable energy generation in 2018. So this some sort of data bar or indicator here is showing the percentage of renewable energy that we have in the year of 2018. Okay, and as we can expect that this renewable energy is still dominated by the hydropower. Okay, generation through the we have the dam, and we generate the electricity using the water. Okay, and then followed by onshore wind energy, and for 8.3%, this is the solar photovoltaic. Okay, it's contribute in 2018 around 550,000 gigawatt hour of potential solar energy, and then followed by solid biofuel 5.5%, and the yellow one here, okay, this is the solar thermal energy here, solar thermal energy, and the total power is around 12,200 gigawatt hour in 2018. Okay, 12,200 gigawatt hour, and you can get a lot of this information. Okay, not only this graph, but you can find the graph of the country. I mean, the energy generated by countries, the ranking of the countries. You can go to this website, www.irena.org. Okay, so you can produce so many statistical data from this website. Okay, so we will start to learn about the solar thermal energy. Okay, there are two ways in which we can harness the solar energy or the energy from the sun. The first one is the solar thermal. So in this technology, we will use the energy from the solar and convert it to the heat. Okay, and this heat can be used to run a turbine, and so will generate the electrical energy. And we can also use the heat that we collect from the sun to produce the hot water production, okay, to be used for house heating or factory heating. The other technology, I think, is most of you already familiar, is the photovoltaic. So this is the direct conversion, okay, to electricity by using the photovoltaic effect. Okay, this diagram show how we can collect the solar radiation from the sun and convert it to solar thermal energy. So in between we must have a solar collector and the working fluid. Okay, solar collector will collect the energy from the sun. Okay, and this energy will be collected or will be absorbed by the working fluid, and this the energy in the fluid can be used, okay, as a heater or heat energy. Okay, so in this bottom diagram we have the sun, and it have a solar radiation. This is indicate the solar collector. Okay, and then we have a working fluid. Okay, from the cool one, when it flow into the solar collector, the energy will be, I mean the working fluid will be heated up. Okay, and then flow to this line, and this heat in the working fluid will be used for heating. Okay, the working fluid that I mentioned before is a sealed circuit of fluid, usually contain a special mix of glycol and water, is pumped around the system. Okay, and then when the solar panel or the collector is heated, so this energy will be passed through the liquid. Okay, and then pass through a special solar coil within the hot water tank. Okay, the heat from the liquid will be transferred to the body of water, and this will heat the water in the tank, and the water can be used, okay, uh, as a hot water in house, office, or factory. So basically, as we mentioned before, the solar thermal is the way we can use the energy from the sun to provide the hot water and heating for the domestic, commercial, and industries process. So this the simple concept that we can understand is if we put a bucket of water in the steel container in the middle of the heat or the sun. After a while, the water in the bucket will become hot. Okay, so the solar collector will work in this concept, but the way it does it is in more efficient way. I mean, all the heat will be going to be transferred to the liquid, and I mean the efficiency of the energy transfer is much better. Okay, this table shows the type of solar collectors and their working temperatures. We can classify the solar collector based on their motion type. The first one is the stationary type, and then single axis tracking and two axis tracking. For the stationary type, the most common one is the flat plate collector, and then we have an evacuated tube collector, and finally the compound parabolic collector. And this type of collector works at low temperature, which is from 30 degrees C until 240 degrees C. The second type is the single axis tracking. This is covered by the linear Fresnel reflector, parabolic through collector, and cylindrical through collector, and they are working in the range from 60 degrees C until 300 degrees C. Okay, for this one is normally for the electrical power generation as well. And then the two axis tracking is parabolic dish reflector and heliostatic field collector, and this is working at the higher temperature from 100 to 2000 degrees C. Okay, both the single axis tracking and two axis tracking are commonly used for electrical energy generation from the solar thermal energy. This is the first type of solar collector, the flat plate collector. Usually this, you can see a large insulated metal box on top of the roof. Okay, so when you can see something on top of the roof, I mean something like this. Usually there will be two types. Okay, when you see something like this on top of the roof, it can be solar photovoltaic, or it can be the flat plate collector. Okay, the solar photovoltaic, that the one that generate electricity directly, but this one, the flat plate collector, usually used for heating. Okay, so most common collector used for home solar water and space heating. And this collector can collect the direct beam and the diffuse solar radiation. So the direct beam, this is the radiation received directly from the sun without having scattered by the atmosphere. And for the diffuse radiation, is the one received from the sun after its direction has been changed or scattered by the atmosphere. Okay, so this is the direct one, and the second one is when the beam or the radiation is changed or scattered by the atmosphere. So this collector can collect both of them. Okay, but for sure the direct beam will have more energy transferred, okay, using this solar collector. So this is several example of the flat plate collector. We can have the glazed one. I mean, the can see some sort of mirror like on top of the building. So this is the glaze collector. And we can have the second one is unglazed, so usually black in color like this. This figure shows the main component for the flat plate collector. On top of it we have the cover plate, okay, this area here. Usually this is the made of the transparent material, and as well the glazing material. And then just below that we have the absorber plate. So this is the part where the heat from the sun is absorbed, okay, and the energy will be used to heat the water or the liquid inside the tube. The tube come from here, the inlet connection, and will go out from here. So the liquid will be pumped into this tube, okay, and the heat absorbed by the plate here will be transferred to the tube and heat up the tube, and the heat will also heat up the liquid inside the tube. So this tube will go to the water tank to heat up the water in the tank, or it will go for the heater inside the house. Just below that we have the insulation material, usually made out of wool or the fiberglass material. So this is to prevent the loss of heat to the bottom of the plate. At the side of the plate we have the collector housing made from the aluminum alloy or galvanized steel. So this is to ensure the structure of the overall structure of the plate. This is the flat plate collector from different view. Okay, in this we can see this is the casing of the plate, and then at the bottom side we will have the insulation material. And on top of that we will have the absorber plate as well as the tube, we call the riser tube, and then it will be covered by the glazing panel here, okay. And then at the end we have the gasket to hold up the plate, and everything will be put into this casing. Okay, this is the processes that happen at the flat plate collector. As you know, the collector can receive the direct irradiance from the sun or the diffuse irradiance, okay, through the environment. Okay, this is part of the energy we receive from the direct irradiance. Okay, so most of the energy can be used, I mean, can be absorbed by the collector and transferred to the liquid inside the tube, but some of them will be lost through reflection and the process of convection. Okay, and some of that will lost due to the heat radiation. Okay, here are the link for the additional videos that you can view to understand more about the solar collector, flat plate collector. Okay, the first one is the water heating system by solar collector Bosch, and then the second one is also the product video by 5-star flat plate solar collector. So you can view both of them to understand more about this technology. Okay, this is the other type of the solar collector, and the name is evacuated tube collector. Okay, from the name itself we know that it will consist of several tubes. So this tube is made of glass tube. Okay, and then inside the glass tube you will have the absorber plate as well as the heat pipe. We need to fill the heat pipe with some sort of fluid to transfer the energy. Okay, so the concept is like this: you have the sunlight here and you have the glass tube. Inside the tube you have the copper heat pipe, and inside the copper heat pipe or the tube here you will fill it with liquid, and one of the material that you can use is the alcohol, some sort of alcohol inside of this. So usually at the bottom of this the alcohol will be in liquid form. So when it receives the heat from the sun, it will evaporate, okay, and turn into the gas, and the heated gas will go to the top of the tube. Okay, and then the top of the tube will be connected to the heat exchanger. So this heat exchanger usually will be placed inside the tank here. Okay, you see the actual product here. So the liquid alcohol from the bottom side of the tube will move up. Okay, the heat itself will move up on top of this, and then it will transfer the heat, okay, through the heat exchanger here. The heat will be transferred to the water inside this tank. So when the heat is transferred, the heated gas will condense and become liquid again, and will go to the bottom side here. Okay, so the process repeats itself. Okay, when the liquid here evaporates and become hot, it will go up here, transfer the heat to through the heat exchanger, and transfer the heat to the water inside the tank. And when it transfer the heat, the liquid inside here will become condensed and become liquid again and move to the bottom. So this process will repeat itself until you didn't receive any more sunlight from the sun. Okay, this is the working principle of the evacuated tube collector. The same as I explained before. You will have the glass tube with high vacuum. So the vacuum itself it serves the purpose of reducing the heat loss through the conduction and convection loss. Okay, because if there are some movement of the liquid here or the material inside here, so it will produce the convection losses. And because we have the as well as vacuum inside here, so we can prevent the conduction losses as well. Okay, so the cool liquid will be here, and then it will be evaporated and become the hot gases around this point, and then the heat will be transferred to the water inside the tank. Okay, and then after it cool down, the condensed gas, which already become the liquid, will go to the bottom of the tube. This is the actual picture of the tube. Okay, the individual tube that be used in the evacuated tube collector. Okay, so this is the part that will become heated when you receive the energy from the sun. This one will be heated up, okay, inside the tube. The cold liquid will move here in term of in the form of gas, and will heat up this part. And when this part is connected to the tank filled with water, this will heat up the water inside the tank. Okay, this is the whole construction of the evacuated tube collector system. So we have a collection or several tube here, and then it will be connected to the tank here at the top of it. Okay, this is the vacuum tube, and then you have a reflector to catch back all the sunlight in the middle of the tube, so the reflector can reflect back the solar radiance to the tube from the back. Okay, to the process of reflection. Okay, the cold water intake come from the inside the house, and then it will heated up during this process, and the hot water will be pumped out from the tank to the system inside the house or inside the factory. Okay, compared to the flat plate collector, this evacuated tube collector has some advantage because it uses a vacuum tube, and this can reduce the convection and conduction heat loss. And then, by having said that, this evacuated tube collector can achieve higher or greater efficiency compared to the flat plate collectors. If you want to know more, you can go to the YouTube video here. This video will explain to you the concept of evacuated tube solar water heater. So this is the product explanation video of one company. Another one is you can also read the how do solar vacuum tube collector work, so from this link. So this can actually give you more insight about this technology. So now we will look at the application of the solar collector. So the most common application is for water heater, in that you use the solar collector to boil the water in the water tank and use for home usage. Okay, this solar water heater use a thermosiphon system. So in this system, the water flows to the system when the warm water rises as cooler water sinks. Okay, so when the sun give heat to the solar collector, the liquid or the water inside the tube will heat up, and it will raise to the upper hot water tank. Okay, and the tube will heat the water in hot water tank, and the cooler water, after it have the heat exchange in this, the cooler water will go down again, and it will be heated up again within the solar collector. Okay, so the requirement for this system is the collector must be installed below the storage tank so that the warm water will rise into the tank. Okay, this is another system that also can be used for water heater. So this one is common. It uses the solar collector, and then the hot liquid in the tube will be used to heat up the hot water in the tank. But in this system, it has another backup boiler, the conventional boiler, to heat up the water in the hot tank in case of, I mean, let's say it's raining season, and the sun radiant irradiant is non available, so it can be used, it can heat up by conventional boiler. Okay, the solar collector is also can be used to heat up the swimming pool. Okay, as we know that in a country that have the cold weather, like the European country, they will use the solar panel when it receive the heat from the sun, can be used to heat up the water in the swimming pool. Okay, for building that have higher capacity like the dormitory, so they will use large set of solar collector like this, array of solar collector that can collect higher amount of energy for hot water system. So this is another application of the solar collector. So in this building, they use the solar collector as a solar dryer, in which they will dry the fruit and vegetable inside the building. Okay, this is the solar cooker. This is a common technology used in India. So they will use this some sort of dish to collect the heat energy from the sun to produce the steam, and they cook inside the building. So if you go through this article in this website, so it mentioned that many places in India use this technology. Okay, and some worship place where many people do the pilgrims in India, they used to cook the meal for them using this solar cooker system. Okay, the next application that utilize solar energy is the solar steel, in which the objective of this system is to produce pure water from the, call it impure water. So the impure water is placed outside of the collector. So through the process of receiving the heat from the sunlight, the water will be evaporated. Okay, and then the pure water on top of it at the plastic side here will be condensed, and then will drip down into the collector. Okay, so this process replicate the way of nature making rains. The solar collector technology can also be used for solar desalination process. So in which we want to produce pure water when we have the contaminated water. So for example, we can put the seawater, the salt water in this container, and when it receives the heat energy from the sun, it will be evaporated to this glass here, and then it will flow and drop at this point when the process of condensation happen. So at this output side, it will produce the purified water. Okay, this application of solar is unique. We use the solar energy from the sun, and by having a specific design of the house can have a natural ventilation system. Okay, so like this, if we have a hot summer sun, okay, the air on the chimney, okay, inside the chimney will be heated up and will be very hot. So the hot air here will go out, okay, through the opening at the roof. So when the air here is emptied by going out from the house, the new fresh air can come inside the house, and this will cool down the house. Okay, this table will highlight the potential of industrial process heating. So it highlight all the process that require heating, okay, in this sector. So the first one is the food and beverages sector. So we can see that many process, okay, required to have the heating element. The same with textile industry, chemical industry, and all other sectors. So this table just mentioned that there are some processes that need the heating, and if we can utilize the solar energy and having a proper solar collector, we can cover all of these industries. Okay, so I believe that's all the lecture for this part. I hope you can take some knowledge from it. If you don't understand anything, you can directly contact me, and you can also text me if you want. Okay, that's all for now. Thank you. Assalamualaikum warahmatullahi wabarakatuh.